everyone, okay, now everyone has got a piece of paper. So now what I would like you to do is please draw a right triangle. Draw a right triangle, please. Finished? Can I have a look? Yes, good. Yes, good. Yeah, good. Yeah, good. Yeah, very good. So, okay. So you draw different right triangles, but there is one thing that is the same in all of the triangles that you were drawing. What is the common thing in all the right triangles?
Two sides are equal.
No. The common thing is all the right triangle has an angle which is 90 degrees. Okay.
Yeah, but I said that two sides are equal, but it can be like this as well. These two sides can be equal to each other, but is this also a right triangle? No. Yeah, so that's wrong, okay? But a right triangle, the two sides can be equal to each other, but not that in a triangle, if two sides are equal to each other, that doesn't mean that it must be a right triangle, okay?
Okay, now please tell me which side in this right triangle is the longest. Say this is side A, side B, and side C. C?
Yeah.
Everyone goes for C? Yes? Okay, very good. This is the longest side. And we call the longest side in this right triangle hypotenuse. Hypotenuse. Okay, so if I draw another right triangle, could you tell me which side in this triangle is the longest?
The top.
Yes, the top side. So there is one way of always recognizing the right side, which is the longest in this right triangle, is the longest side, which is hypotenuse, is always the opposite of this 90-degree angle. Okay, so anyone have got some questions about this right triangle? No? Okay, good. So actually, many years ago, maybe hundreds of years ago, there is a mathematician who is called Pythagoras, and he found out that if this side, the length of this side, side A, is A, and the length of side B is B, and the length of this hypotenuse is C. What Pythagoras found out is that A squared plus B squared is going to be equal to C squared. And this is what we call Pythagoras theorem. So actually, you may ask me, why is it true? I couldn't just believe you because you that this is true. So how can we prove that this equation here is true? So now I'm going to give you, each one of you, 4 right triangles. Yes. Sorry, can you guys just share this? Okay, so now you can say.
So you can use these 4 triangles, red triangles, to make up to a square. Use the 4 of them.
Can you think of a way of moving these 4 triangles so that they can form 2 squares at the same time? It doesn't matter which one is bigger or smaller, or they don't have to be the same. But can you think of a way of placing it however that they can
Put them
form
into
2
one
squares
shape.
simultaneously?
1 or 2?
One shape. Into one shape. Using
But two.
these 4.
2.
But 2 squares,
Yeah.
not rectangulars.
Yeah, 2 squares.
Two squares, not red.
So this is rectangular, rectangle, right? Rectangle, square.
So
The 4
can-
sides should
yeah.
be the same.
Using all of them.
I think it's like this.
2 or
Yeah, that's very good. That's one way of doing it.
Yes,
So it's
well
like-
done.
shapes or 1?
Well
That's
done.
one shape.
1 square.
Yeah, one square, but you can see 2 here, but it's one shape. Very good. Maybe you can think about what are the implications of this one, and does it have anything to do with the formula there? Just using this shape.
Probably I didn't make this clear, but these 2 legs are different. The length of these 2 sides are different. So if you put this side and this side, and actually you can see that the length of these 2 sides are different. So if you put them like this way, it should be a rectangle rather than
Square.
rather than a square. So it's like this. Okay, good. So here, so you can spend maybe 2 or 3 minutes discuss with your peers, or you can think individually. Think of what are the implications of putting
Of
this 4 triangles together.
Like that, yeah. As you
Why
can
it
see-
has something to do with this equation here. How we can actually use this picture to prove that
Yeah, formula.
Pythagoras, this Pythagoras theorem is true.
Please, any ideas? Do you know? Do you know?
No. Maybe I'll give you a hint.
Yes.
So think about the area of this shape. So how can
yeah.
you represent the area of this shape?
these are all the same.
Yeah. So there are
Is the area in the middle?
yes, area in the middle and the area the outer side.
Yeah, so that
Inside equals outside.
area equals that times that. Like essentially,
So this
that's what it was.
is a square and this is also a square, but this one is a little bit of bigger, right? But how can we represent this, the area of
Oh,
this
so it's
bigger
Those two
square?
and that one? I don't know.
So
This square or the big one?
the big one, how do we represent the big one? The area of the bigger one.
That and that equals
This one. So we can use the area of this, the area of this, the area of this, and the area of this, and the area of this. If we add them up together, that will be the area of the bigger square,
Right.
right?
So if we get the area of this
Yeah. First, yeah,
and then times it by 4,
yeah, very good. And then you add, and then you plus the area of this smaller square. Then that will be the area of the bigger square. Yeah.
Okay, now attention here. So, as you can see, how to calculate the area of this big square here. Can anybody tell me?
How do we calculate
all
it?
the areas of the triangles.
Yes, this big, the biggest square
all of
here.
all of the 4 little triangles.
Can we represent it more directly? Just
So,
think about this.
I thought we were finding C. Is that the area?
The C.
yes, so there are actually 2 ways of calculating the area of this square, right? One way is that, can you see this side? Is it side? Oh, yeah.
The length of the side.
This side, and then this side. So the area of this square can be calculated by
That's the length of this side.
The length
If
of
we
this side
times
times
itself,
this side.
it will be the area of the bigger one, right? So we can just think about it as a square. And the side of it, the length of it is a plus b, right? Because that's a, that's b. Right? The length of this side would be a plus b. So if you want to calculate the area of this square, it would be a plus, sorry about this, a plus b bracket and then squared, right? With the length of the side and times the length of the side will be the area of the square. So, yeah, that's the area of the bigger one. But what is equal to? It equals to the area of this 4 right triangle. Then we plus the smaller square, the area of this smaller square, right? So how do we represent the area of the 4 right triangle? We have already got the length of the 2 legs, right? How do we use A and B, the length of these 2 legs, to calculate the area of the right triangle here? No ideas?
The A squared plus B squared?
But it's squared.
The area of the triangle, not the length of this, but the
I don't know, we
area.
haven't done area.
Hang on, I'm confused because you both said different things.
yeah, but yeah,
So you said the area was that, and then you're saying it's all those 4 triangles, so I don't.
yeah. So how do we get this formula? We get this by equal these 2 together. So I was saying that the area of it is a plus b bracket then square. That's perfectly right. And she said that the area of this one is the full area of the rectangle here, and then plus this one. That's right as well. And if we use this one to equal the one that she just said, if we equal them together, then we can have an equation. So that's how we get this.
Okay.
So
It's already half past almost.
It's 30 minutes now.
Yeah, 30 minutes to go. So just,
Okay.
we need to fit in enough time for
okay,
the
so
girls.
sorry.
Okay.
That's okay, we just want to do reflection and then enough time for the